Hello guys, welcome back to Backpacks Academy. So today we are going to solve this question. Uh, this is a comprehension question where it says the equation for a state of gas is P equals to RT by V minus B minus A by T into V square, where V is the molar volume of the gas and A and B are the van der Waals coefficients or the van der Waals constants. Then they are asking you the value of TC, VC, PC. Okay. So before starting this, I would be covering about compressibility factor and van der Waals equation and liquid. Yeah. So first, my first topic will be van der Waals equation. Sorry, compressibility factor. While solving this compressibility factor, in my first video of gaseous state, I have been telling you guys that compressibility factor is simply the ratio of PV by nRT. Okay. And for ideal gases, it equals to 1. Okay. Z can be less than 1 and Z can be greater than 1. The name itself says it's compressibility factor, right? So that means if Z is less than 1, then it's easily compressible. If Z is greater than 1, it becomes a bit harder to compress it. Okay. That's okay. So I'll be discussing a few graphs. Okay. Mm, Okay. So this graph is Z versus P. Okay. So this, if this value is Z equal to 1, then this is for ideal gas. And this is for hydrogen and this is for helium. These all are for other gases. Okay. Now, again it's Z versus P graph. Just to discuss about the temperature. Okay. Let us assume this is T2 and this is T1. Okay. Then how do you give the relation between T3, T2 and T1? It's very simple. See, Z equals to PV by nRT. Okay. Now, uh, if you increase the temperature, then your Z value decreases. Here you see that for T3, at temperature T3, Z is increasing with lower rate than T2, than T1. That means T3 is greater than T2 is greater than T1. Okay. That's how you do it. Now, the other two important graphs are your isotopes. This is P and this is V. the same exact graph will come. Okay, so this is for your ideal gas and this is for your hydrogen gas. Okay, and the same thing doesn't happen for either hydrogen or helium. Okay, if this is your ideal gas, then this will be your real gas. Okay, next, coming to Van der Waals equation. See, whatever the equation which we wrote, PV equals to nRT. Okay, before coming to Van der Waals equation, this equation is for ideal gas, and every ideal gas satisfies this equation. Okay, this is what actually happens. Now, I think I forgot something else. Yeah, very simple part I forgot. If z is greater than 1, it's positive deviation, and if z is less than 1, it's negative deviation. Okay, this is the point which I forgot. Now, this PV equals to nRT. Actually, it's obeyed by ideal gas. But we do know that ideal gas aren't the one which exist everywhere, right? They exist at certain conditions for certain gas. Okay. Yeah, this PV equals to nRT is satisfied at certain pressure, volume, and temperature conditions. Okay, that we will be speaking later. Next, next thing is about Van der Waals equation. What's this Van der Waals equation? See, he just gave the equation for real gases. Like most of the scientists tried to give some good equation for the real gas, in which Van der Waals equation is like the most, you know, he came near to giving a equation which is mostly satisfied. Okay, so in this, he introduced his two constants. One is A and one is B. Okay, basically he told that P ideal will be, sorry, not P ideal, it's P correction. Pressure correction is proportional to N by V square, whole square. So that is AN square by V square. Okay, and what does this it in future? See, there are A has a it has some significance, which like it only indicates about your attractive forces. Okay, A says about your attractive forces, and if your attractive forces dominate, then A will dominate. Okay. Next, uh, so what did that become? It becomes P plus A n square by V square. This is like the P dash, and your volume correction. You can read about the significance of A in your NCERT book or some any other standard book if you are following that. Okay. Then coming to your volume correction, here, you know, he gave that volume correction is V minus NB. Okay, where B is again van der Waals constant and its value is always proportional to R cube, where R is the radius, and for 1 mole it's equals to 16/3 times pi R cube times Na, where Na is your Avogadro number. Okay, and B represents about your repulsive forces. Okay, if repulsive forces are given, then are dominating, then B dominant, obviously. Okay, so the whole equation of van der Waals is P plus A n square by V square times V minus NB equals to nRT. This is the van der Waals equation. Okay, where N is number of moles and all other things are known to you before. The only new things are the pressure correction and volume correction, A n square by V square and NB. Okay. Also, next one will be, see, if you are dealing with high pressure, then you can neglect with this part. A is neglected because in future when you might be studying either in your maths or physics, that the more the higher the value is, the less the error becomes. See, like if your value of P is, let's assume your error is like 0.1. So let's assume that your pressure value is like 1 bar and your error in pressure is, okay, let's assume that your pressure is 2 bar and error is 1 bar. Then obviously the value that it's like high error in your pressure. But whereas similarly, if your pressure is like 100 bar and your error is still like 1 bar, then the value of error had decreased, the percentage. And similarly, like you increase your pressure, the value of error becomes like negligible. That's what I want to say, that the higher the pressure is, the less the this will be. And similarly with V, higher volume, that implies B neglected. Okay. When attractive forces dominate, A is there, B will be neglected. And when repulsive forces dominate, B is there, A is neglected. Okay. Okay. So sometimes, and your value of compressibility factor is always greater than 1 for hydrogen and helium, which is known to you. Okay. So if your attractive forces dominate, then we discussed that your B is neglected. Okay. Then what happens? Okay. Let us assume the value of N is 1. Then it is P plus A by V square into V equals to RT. Okay. Then PV plus A by V equals to RT. Now divide the whole equation with RT. Okay. You know that this value is Z. PV by nRT is Z. Okay. This is the equation when your attractive force is dominant. Okay. And your van der Waals equation similarly becomes this. When attractive force is dominant, this is your van der Waals equation. P plus A by V square into V equals to RT. Okay. Similarly, when repulsive force is dominant, similarly when your repulsive force is dominant, your your A is neglected, then it is P plus 0 because A is neglected times V minus B equals to RT. So your P into V minus B equals to RT. This is what your equation is. And again you multiply this PV minus PB equals to RT and PV equals to RT plus PV. Now divide the whole equation by RT. Then this value I am writing it here. Z equals to 1 plus PB by R. This is the equation. So that's the equation for your when your repulsive forces dominate and attractive forces like are much higher. Like the repulsive forces are more higher than the attractive forces. Then this is your equation of compressibility factor. In these both things, you can actually observe one thing, that if your repulsive forces dominate, then your A value is neglected and your Z value is 1 plus PB by RT, which is always greater than 1. That means it only shows positive deviation. And this is always less than 1, negative deviation. Okay, now coming to Andrew curve or the liquefaction of gases. See, basically here we are gonna discuss about critical volume, critical temperature, and your critical pressure. Okay, so thing is like there was a scientist whose name was Andrew. He observed a particular graph for uh, carbon dioxide. While he was converting that into a liquid, he observed few things. Okay. That's what we are gonna discuss more. Wait a minute. I shall just copy paste the image, and with that I will be discussing. So let me show you the picture of the book from this book. Yeah. So I think you are able to observe it, right? So here basically what did Andrew observe? Oh, it's the name of scientist. Uh, like you can see here the volumes V1, V3, V2, V1, right? And pressure values P3, P2, P1 and this. Until this point, he kept starting at A. Then he tried to, while reducing the volume, he came to point B, C, D, which he brought into graphs. And in these graphs, what he wanted to say is, see, from A to B, before the temperature 30.98, which is the liquefaction temperature or the critical temperature, where carbon dioxide is getting converted into liquid. So in this region of A to B, it's completely as gas. Okay, and in this region, they both coexist as liquid and gas. At this whole region, it says liquid. Okay, but whereas here you see that you know here this portion from H to E, it's like liquid, and here it's from either A to E, it's like uh, A to E. It's simply, what do I say? Mm, It's gas. Okay, again it's a gas. That's what he observed. Uh, and what is this E? At this E, you are having P3 and V3, which are your critical volume and critical pressure. So, coming back to the definition of what is critical volume, critical pressure, critical temperature. Critical temperature is the temperature, the maximum temperature where you can liquefy your gas. So, here, beyond this 30.98 degrees Celsius, if you like, if your temperature is even 31 degrees centigrade, it doesn't get liquefied. It remains as gas. Okay. And what is critical pressure? It's the minimum pressure which is required to, liquefy your gas, to convert your gas to liquid. So, what's the significance about the Andrew curves is, before this, while observing these isotherms, before the the critical temperature, the liquid and gas actually they are in the coexisting. What do you say? They both coexist. Uh, this book is Ville. They, if you want to go through this book, you can go through this book. Yeah. So here in this region, this is the region where, like, if you draw any other isotherms as well, before this E, below this E, what do you observe is that there will be always some region where the liquid and gas coexist together. Okay, that means they both exist in the equilibrium, physical equilibrium. That's what he told. Okay, that's what I wanted to discuss about the Andrew curves. Okay, now coming back to Viral's equation. I hope you understood this. If you didn't understand anything, then please do let us know while writing it in the comment box. Okay. Next, Viral's equation. Sometimes you might be asked questions based on this Viral's equation. Beyond advanced, I think, uh, like they will just ask you what is the coefficient, second viral coefficient, what is third viral coefficient. Okay. Viral's equation. It's very simple. Your P plus A by V square times V minus B equals to RT. Then your P V minus PB plus A by V minus AB by V square equals to RT. Or your P plus A by V square equals to, we'll just drop off this line because it doesn't let us reach the Viral's equation. I think it let us, but calculation would be a bit difficult. So your pressure equation is RT by V minus B minus A by V square. Okay. This is what your pressure equation is, right? Okay. So again, you convert this by dividing it with RTV. Your equation should be like PV minus by RT. This is what you want from the above equation. Or let us write this line as well. PV plus A by V minus AB by V square is to RT. And you divide the whole equation by PV by RT equals to AB by V square RT V square minus A by RTV. Okay. So this is your compressibility factor Z. Okay. And your Z is it, you are taking A and RTV is common in both of them. Okay. A by RTV times B by V minus 1. Okay, so here I am facing a bit difficulty while manipulating this equation, but you know, uh, what actually happens is while it's like you actually expand binomially this part. Okay, while you expand it binomially, then it becomes this equation. Yeah. So while you binomially expand this is what you get. And while you compare the coefficients z equals to 1 plus b minus a by rt times v plus b by v square plus b by vq. This is how your equation need to be. I don't know why I am not able to manipulate it today. Yeah. If you want to, you can go refer your standard books and you can actually get them. Okay. So You can sometimes you can neglect these terms. You know, you will get to know about this all things in your mathematics or physics. You actually can neglect these terms most of the time. Then your equation is z. Okay, this is what is your equation, right? So what is happens is, if you put your z value is 1, then you get 1 equals to 1 plus b minus a by rt into, it's like 1 by v, sorry. Okay. Then what are you getting? T equals to a by rb. This is the temperature at which, this temperature is actually called as Boyle's temperature, where every gas behaves as uh, ideal gas. Okay. Because your compressibility factor is 1. That's the reason why every gas behaves as your ideal gas. And you also have another term called inversion temperature, which is just the double of Boyle's temperature, and the ratio is, it's denoted by TB, and TF by TB is always 2. Okay, sorry, it's TI. My bad. Okay, so it's TI by TB, and sometimes you might be asked about, just remember the value of inversion temperature. It's 2A by RB. Okay, and Boyle's temperature is A by RB. This is what I wanted to discuss about the Viral's equation. Now coming back to our question. In this question, I told you, right, I would let you how to derive your uh, equation, like your values for TC, VC, and PC. Yeah. So here in this question, they actually changed the value of pressure. Basically, your pressure equation is, but here they gave extra T. There means some other gas will obey this in some other hypothetical world, or might be the real world as well. Sometimes some other gas. And he gave in the question that A and B are your van der Waals constants. Okay. So how do you find C? He just gave you to find, this is your TC, this is your PC, and this is your VC. Okay. It's easy. Let me show you the graph. Then it becomes easy. Yeah. So here you see this E point. There is like a sudden change. And this E point is actually called as your point of inflection. What is the significance of point of inflection? You will learn that thing in your calculus part while you are studying the maths. You know, uh, basically the definition is that dy by dx equals to 0, and d square y by dx square is also equals to 0, but your d cube y by dx cube is not equals to 0. This is what your point of inflection is. You know, it's actually dependent on concavity, I guess. Either it's the graph is convex or concave. I don't know. But yeah, that's that's the brief idea which I can give you about the point of inflection right now. Okay. So now what are we gonna do is, To find PCVC, first thing is dP by dV equals to 0. This is what we are going to perform. That means d by let me see the equation. RT by V minus B. Okay. This is what your equation is. And this will be equated to 0 because E is called your point of inflection. Okay. Now, while differentiating this, it's your partial differentiation actually. Okay. This value is equated to 0. Okay. And from this, your RT by V minus B whole square is equals to 2A by T times V cube. That employs your T square R equals to 2A V minus B whole square by V cube. Okay. Let's keep it like that. We'll get to know that which equation we should actually be using. Okay. And let's okay. Now this is your dou P by dou V. Now what you do is as its point of inflection, this is also equated to 0. So while you differentiate this, you get 2 RT by V minus B whole cube minus 6A V by 4 V power 4. This is equals to 0, right? So this cancels it by 3. What you are getting here is RT by V minus B whole cube equals to 3A T into V power 4, right? Now, yeah, this equation you're gonna use it again. Let's name this as A and this as B. So what you do is A by B. Then what you are getting is RT by V minus B whole square by RT by V minus B whole cube. RT gets cancelled. This is equals to 2A by TV cube by 3A by TV power 4, right? A gets cancelled, TT gets cancelled. Only here V and here only one V is there. Okay. So your overall equation is V minus B equals to 2 by 3 V. So V is equals to 3V. This is what you are getting, right? So your VC is 3B. Now, while calculating your PC, for PC, no, we shall be first calculating your TC with this equation. Let us name this equation as some C. Then it's T square R equals to 2A times 3B minus B 2B whole square by 3B whole cube, right? So T square R is equals to 8AB square by 27B cube. Then your TC is root A by 27RB. This is what your TC is. Yeah. And now for your PC, you just substitute your P value here. I mean your T value and V value. Then you will get your P value. So what is it? P equals to RT by 2B minus A by T into V square, right? Then it is 4B square. Now you take its LCM, then you're gonna multiply this. First we'll substitute. Or we shall first do some arrangement in the equation. Yeah, so what's the arrangement? It's RT square by 2B square E minus A. This is what your equation is like. Now you can simply happily put your P to R to T square. So your T square is 8A by 27RB into B minus A, right? And similarly 4B square into 8A by 27RB. While solving this, what you get? 16A by 27B, 27, and yeah, so the equation is 2R T square B minus, did I miss something? Let's try solving it here. P equals to RT by 2B minus A by 4B square T, right? Then P equals to RT square B to RT square B, right? By 4B square T minus A. This is the equation which we are getting, right? Oh, sorry. This is 9B square. Okay. Then you are gonna multiply and it's gonna be 18. And it's gonna be 9. So 9 RT square and it's 18B. Now I think you can happily solve this. 8A by 27 RB minus A by 18 B square into root 8A by 27 RB. What do you get by solving this? R gets cancelled and I think you're left with factor B. Yeah, this 3. 8 by 3. So it's equals to 2a by 3 times b square into 18 is here, 8a by 27 rb. So here you will be having the factor of b cube, and inside it's gonna be 18 square. Then it's 3 and it's 2, and again it's 6. So 8 into 2 into 6. Then your value is 2a by 3. 8 into what's this? 8 into 2, 16. 16 into 6, so 12, 96. 96 a b cube, right, by r. Now with options, I think we will be able to find it. Yeah, so I think this is your answer. Yeah. So your PC is AR by 216 B cube, because we are not getting 227 B square, 27, and we aren't getting any B square term. You are getting B cube. So yeah. So with this, we have finished our gaseous state. Now we will be moving to thermodynamics and thermochemistry, followed by equilibrium. Then your physical chemistry is done. So I think within another 2-3 weeks, your physical chemistry of your 11th grade is done. Then again, we will be starting with either organic or inorganic. Yeah. So thank you guys.